Okay, so I'm going to be doing number 7 on the chapter 4 homework. So this question basically gives us a situation where the acceleration of an object is not constant, and we have to do vector integration in order to achieve the position equation. So we're given this equation for acceleration, a equals 6 square root 2 tj, which I believe is the vertical component, and we're going to have to integrate it using initial velocity equals 5I, which is the horizontal component, and initial position equals 0. So we know that velocity equals the integral of acceleration. So plugging in the equation, we get v equals integral 6 square root t dt j, vertical component, and just integrating this, we get 4t to the 3/2 power j plus c, which is our constant. We can solve for the constant using the initial position, which we're given here. V of 0 equals 5i. 5i equals 4 0 to the 3/2 plus c, which gives us c equals 5i, which we can add into this equation here in order to get the velocity equation. 4t to the 3/2 j. Alright, so notice that now we have the velocity equation, which is in two components that we're going to have to integrate separately in order to get position. So position equals the integral of velocity. So if we want to integrate this separately by components, we're going to take first the integral of the horizontal component and then the integral of the vertical component, which is going to look like this. You don't have to write them separately, but just for like visual ease, I did. So position equals 5t, just integrating this half, and plus the second half, which equals 8 over 5t to the 5/2 j, plus d, our constant, and again solving for the constant, initial position equals 0, so the constant just equals 0, which means we can cross this out, and we get the final position equation, which is x equals 5ti plus 8 over 5t to the 5/2 j.